a conflict. So an operation, so an instruction I of transaction Ti is said to conflict with another instruction Ij of another transaction Tj if the following thing happens, is that they both access the same data item. This is very, very important, same data item, correct, and at least one of them is a write operation. So now one can intuitively see why are they said to be conflicting. If you remember, there are this RAW, read after write, then write after write, and write after read conflicts. Okay. Now what is the problem? Why are they said to be conflicting? This instruction II and instruction Ij of two different transactions. They must be of different transactions, number one. Then they must be accessing the same data item, and one of them must be write. Now why is this called a conflict? Is very simply the following thing, is that suppose II should have taken place before Ij. Now they are conflicting because in another schedule which is equivalent, this order of II and Ij must be preserved. It cannot happen that in the another schedule Ij is before II and then it is not equivalent. Why it is not equivalent? Because you see that these read-write conflicts, write-write or write-read conflicts will happen. So that is why they are said to be conflicting, and these two are, this is the essentially the definition of why they are said to be conflicting. So intuitively, this a conflict is this enforces a logical temporal order on those instructions, right? This is a logical temporal order. They cannot be violated. That logical temporal order cannot be violated, right? Now that is one thing. Now on the other hand, the other side of it is that if there are two instructions which do not conflict, then they can be interchanged and they can be placed any one before any other one, and that is not a problem. So that is the other side of it, and that is what is we are going to study in much more detail. Okay. So conflict serializability. So this is the conflict and we have studied serializability. So the next thing what we will do is we will study what is called the conflict serializability. So first of all, a schedule S is conflict equivalent. This is called a conflict equivalent to another schedule S dashed if S can be transformed to S dashed by a series of non-conflicting swaps of instructions. So non-conflicting swaps of instructions. Alright, so what does it mean? So suppose there is a schedule S and then there are some instructions in it, of course, and then let us pick any two instructions within S, and if they do not conflict then they can be interchanged. So let us interchange it and let us keep on doing this, and suppose by the process of this one gets to S dashed from S, then S and S dashed are conflict equivalent, because what they have essentially done is that they have ensured that if two instructions do not conflict, they have been swapped. So on the other hand, which also means that if two instructions conflict, their logical order has been maintained. So the conflict are, these two schedules are equivalent in the sense of the conflicting instructions. The conflicting instructions maintain the same order. So that is why they are called conflict equivalent. So that is the definition of conflict equivalent. Now this is the first definition. Now S is said to be conflict serializable. This is conflict equivalent. Conflict serializable. This is a definition again. If S is conflict equivalent to some serial schedule. So once more, S is conflict serializable is equivalent to some serial schedule. Okay, so it does not need to be conflict equivalent to all the serial schedules, but there must exist at least one serial schedule that S is conflict equivalent to, and then it is called conflict serializable. That is the definition of conflict serializability. Now why are we studying it? Because if a schedule S is conflict serializable, that means that it is equivalent to some serial schedule. That means it will preserve the database consistency, because we know that if the transactions take place one after another serially, then they preserve the database consistency, because each transaction by itself preserves the database consistency. So if transaction T1 happens, then it preserves the database consistency, and then T2 happens, then it also preserves the then it also preserves the database consistency. So if there is another schedule which even though it interleaves T1 and T2 is conflict equivalent to it, then it also preserves the database consistency. So now let us see an example. So suppose S is the following. So we will use the same notation, and we will even drop the semicolons. Alright, so the first question is this conflict serializable? So that is what we will be trying to answer. That means to say that whether this is conflict serializable or not, it must be equivalent to either, so there are only two transactions T1 and T2, so it must be conflict equivalent to either T1 T2 or to T2 T1. Fine. So now let us see whether it is conflict equivalent to T1 T2. So first of all, so T1 T2 is the schedule. So what is the T1 T2? We will write down all the instructions of T1 first in the order that they appear, that cannot be violated. So R1B, then W1B, and then all the instructions of T2. Okay. Now we will see that if we can arrive at this from S through a series of non-conflicting swaps. Okay. So now what is the first thing? So first thing is that let us see how to do it. This is fine. There is no problem with these two. Similarly, these two have no problem because they had been starting and they had been ending. So now what has been swapped is essentially, one can say that R2A and R1B has been swapped, right? Because this R1B has come here and R2A has come here. So are these two instructions non-conflicting? Yes, because they do not operate on the same data item. Fine. Very simply, so these are non-conflicting and this swap is fine. And how about these two? Then these two have also been swapped. W2A has been swapped with W1B because W1B is coming here and W2A is coming here. Are these two non-conflicting? Again, it is yes, because these two are on a separate data item. So that means that S and T1, T2 are equivalent. That means S is conflict serializable. So the answer to this is S is conflict serializable. So there is no problem with S as far as database consistency is concerned. Now note that we only needed to test with T1 T2 and not T2 T1 because it has to be conflict equivalent to one of them. That's it. So since it is already passed in the first test, it is fine. It need not be checked with T2 T1. If these were not equivalent to T1 T2, then it needed to be checked with T2 T1, not other there. I mean only when T1 T2 did not pass the test. That's the thing. Okay. Now let us take another example, which is the following. S is simply R1A, W2A, and W1A. This is a very short schedule, and let us see whether this is equivalent. So what is T1 T2 is R1A, W1A, W2A. Now let us test whether S is equivalent to T1 T2. Okay, this is fine, but this has been swapped. So these two, this has been swapped. Now is this a non-conflicting swap? Can we do that? Let us test it. they operate on the same data item and one of them is a write. So that means these two conflict, these two instructions conflict. So this swap is not a good swap, so that means S is not equivalent to T1 T2. Fine, but we still cannot conclude anything about S, we need to test it with T2 T1 as well. So what is T2 T1? T2 T1 is simply W2A, then R1A and then W1A. Fine. So now let us see whether this is equivalent to S. So once more, W1A is the last operation, so nothing to be worried about, but R1A and W2A has been swapped. So let us see if that swap can be happening. Now R1A and W2A are on the same data item and one of them is a write, so this also conflicts. So this is not a non-conflicting swap, so this is also not equivalent. So S is neither equivalent to T1 T2 nor it is equivalent to T2 T1. That means it is not conflict serializable. So that means S will not preserve the database consistency in some manner. So in the sense of conflict serializability. So S is not conflict serializable. That's the concept of conflict serializability.